This is the most known as well as favorite childhood story of all of us, right? Who is the winner of this race? We all knows it. Yes? Whether it is the race between the tortoise and the hare, or it's between the Supermans, or if it is going to be a car race, all will be decided based on the amount of time taken. Do you know the concept of work and energy? Do you know the positive and negative work? Can you define 1 joule? What does mean by the term energy? We will learn all these basic concepts now. Work and energy. In our daily life, we do a lot of different work and get energy from variety of food that we eat in our daily routine. But when we study work and energy in physics world, their definition and concepts get at 360-degree rotation. For example, if a builder builds a wall, he may say after the day job that he has done much work. But in reality, he has done zero work. In physics, work is defined as the energy transferred by a force and its own direction. In simple, I can say that when you displace an object in the direction of your force, we can say that according to physics, we have done some work. For example, a box is present over here on which I exert a force in a particular direction. The block moves in the same direction of force then we can say now that I have done work according to physics rule. So remember this convention of physics that whenever a force displaces an object in its own direction, we will call this displacement of the object is due to the force as a work. Now, if we consider another block over here, force is applied towards the right direction and the block moved towards the downward. Now, can I say that I have done work on this object? The answer is absolutely no. One can say that I have exerted a force on an object and the object is displaced by my force. So according to the definition, I have done some sort of work. But still, this is a wrong explanation. Here is the explanation, that is, the work done is zero. You have exerted a force on this object in the right direction while the object is displaced in the other direction. Hence, the direction of force and the direction of displacement are not same, so that the work is zero. Here, remember the simple rule that the direction of force and the direction of displacement should be same so that the work done can be maximum. Let me discuss the formula of work. The formula of work is equal to force into displacement into cos theta. If someone writes F cross D cos theta, then this is the wrong formula because the work done is a dot product. Work done is not a cross product. Thus, we already knows force is exerted on the object and the object is going to have a displacement along the same direction of the force. Then what about cos theta? Well, the theta is the angle between the force what we exert on the object and the displacement of an object. Let me explain the work done formula by giving you some examples. If I apply 10 Newton of force on the object in the direction, then the object travels 20 meter in the same direction. Here I know that the direction of force and the direction of displacement is same. Hence the angle between them is 0. Therefore, here theta is equal to 0 degree and we already know that cos 0 is equal to 1. I know the formula of work done, which is work done is equal to force dot displacement dot cos theta. By substituting the values into this formula, we get work done is equal to 10 Newton times 20 meter times cos 0. Then I get 200 Newton meter or 200 joules over here. Remember that there are two different units for the work done. They are Newton meter and joule. So in this example, we learned that the work done is maximum when the angle between the force and displacement is 0. Let me give you another example. If you apply a force of 50 Newton on an object and if the object displaced by 30 meter in the same direction, then what about the work done? Well, here the angle between the force and the displacement is 90 degree, hence theta is equal to 90 degree. Now writing the work done formula, work done is equal to force times displacement times cos theta, where the force is 50 Newton and 30 meters the displacement cos 90. We know that the value of cos 90 is 0. Hence, the work done now is 0 Newton meter or 0 joules. So in this example, we learned that when the angle between the force and the displacement is 90 degree, then the work done is 0. That is why I told you previously, when the direction of force and the displacement is different, then the work done is 0. Let us discuss the concept of positive and negative work done also now. First of all, remember that work done is the scalar quantity. Therefore, the work done may be positive or negative. If you exert a force on an object in the shown direction and the body moves in the shown direction, then the angle between the force and the displacement is 0. We also know that cos theta is equal to 0 means 1. Hence here the work done is positive. On the other hand, if you exert a force on an object in the shown direction and the body moves in the opposite direction of the force applied, hence the angle between the force and displacement is equal to 180 degree. We already know that cos 180 is equal to minus 1. Hence, here the work done is negative. Here, the negative sign indicates that you exert a force in the direction opposite to the displacement. In real life, when we raise an object, when we raise an object from the earth's surface, the displacement will be like as shown over here, and the force will be towards the downward as it is gravity. Hence, the work done against the gravity will be negative. Now, let us learn the concept of energy. Energy is explained as the ability to do work or the capacity to do work. As we learned that we do some sort of work when we displace the object from its actual position to another position. Or we can also say that when we do a work on an object, the work produces the motion of an object, which already shows that it possesses the kinetic energy. Hence, we can say that when we do some work on an object, it changes its energy associated with that. Here the object is in motion, so the work done is going to be given by the change in kinetic energy of the object. The SI unit of work is joule. The SI unit of energy is also joule. Remember that energy can be transferred from one object to another object. There are different types of energies like kinetic energy, potential energy, thermal energy, chemical energy, etc. Now let us explore what is 1 joule? 1 joule is equal to 1 Newton meter. That is, it can be defined as when you exert 1 Newton of force on an object, if the object is being displaced by 1 meter distance, then the work done is 1 joule. A powerful lineman is both strong and fast because the force and distance are high. When it comes for the person while climbing, he spends more power because he spends less time for each step what he is taking. The lineman and the climber shows the relation between the work and the power along with the time. So we can define the power as work done in the given time, where we know work done is force times displacement, and the power can also be written as power is equal to force into displacement over time, where the displacement over time is velocity, so the power can also have the formula force times velocity. Then what is the unit of power? The unit of power is watt, or it will be used as horsepower. Now there must be a question, what is 1 horsepower? So the amount of work done by the horse in 1 second is called as 1 horsepower, which is equal to 746 watts. So according to physics, work is the force applied times the distance. When it's the general definition for work, wherever we are using the force to do something, like opening the door or lifting the groceries, climbing the stairs or throwing a ball. When it comes for the energy, it's the ability or the capacity to do work, like running up stairs or walking. The same thing was going to be there for the power as well, but it is going to tell you how quickly you have done the work or how much time you have taken to do that work. So in general, the work, energy, power, all these three are going to be interrelated with each other, where the work is nothing but how much amount of energy you spend, and power is nothing but how much amount of work or how much amount of energy you spend in the given time.